Hello, everybody. Welcome to the Life on Mars podcast. This is the English edition of the MarsBased podcast. This is yet another edition, yet another episode where we're talking with friends. In this case, talking to the man, the myth, the legend, Mr. Dorion Carroll from the other side of the pond, directly from, I think you are in Seattle right now. Are you in Seattle?
Yes, I am. Hello, everyone.
How are you doing? Good morning for you.
I'm doing great. Yeah, it's a nice morning. It's a national holiday, so I'm having a chance to take a break from regular work and do something fun with friends.
Great. Yeah, that's one thing that we've been doing this podcast. We launched 1 month ago, and so far everybody we've interviewed we consider a friend. So maybe we need to rename it to the MarsBased Friends or something like that podcast. I'll introduce the speaker for today or tonight. I don't know what people say on podcast, today or tonight, but basically Dorion has been working on the tech side of things and in America, in the US for many, many years. Started off in Oracle, if I remember correctly, been working for a bunch of companies, technological companies like Excite, Electronic Arts, Bustini, Technati. There was also one of your last spells was the CTO, CIO at Zynga. And right now you're VP of Customer Engagement Technologies at Amazon. So what is that title? What does that mean? And maybe you want to introduce yourself a little bit better.
Oh, sure. Thank you, Alex. So customer engagement technology is a area of our customer service technology teams. I run the largest team within worldwide customer service. And we're responsible for all of the self-service and automation tools, bots and AI, machine learning that power a lot of the automated components of what customers can interact with. But then we also have to develop the tools that our customer service associates. We have tens of thousands of them around the world in, 50 different countries. And we have to be able to do machine translation. We have to be able to help them for every last product, service, feature, device, digital media, anything that Amazon does, we have to provide customer service and technology solutions for that.
You've been well, we have been commenting on what could be talking about today. And one of the things that we always talk the most, because you're a developer, I'm a developer, and one of the things that really, I think, fascinates me is your extensive background in technology, all the companies you've seen, all the sectors you've seen. But there's one thing that doesn't change, which is software maintenance, right? You might have seen the evolution of the sector over the years, but one of the things that we're seeing right now is that disruptive technologies that they disrupted the market, and companies 10 years ago are becoming obsolete now, even some things that were programmed 5 years ago. So let's talk a little bit about the concept of tech hygiene that you brought up in our earlier conversation. And how do you approach these things as a CTO, as a VP of technologies and in companies? How do you keep the house tidy?
Yeah, tech hygiene is sort of the way to address or prevent technical debt. Whenever you're designing and building software systems, there are always trade-offs you have to make. And I think one of the false trade-offs that people often make is speed versus quality or hygiene. And if you're building something and it's relatively standard, speed may not make that much sense because you're likely to have to operate it for a very long time. The other thing that people often do is they cut corners and build monolithic systems because they think that's easier. At the end of the day, again, if that system survives a year and you're operating it a year out or 2 years out, 3 years out, 10 years out, that monolith is going to get in your way. I've worked on so many systems. I've built systems that end up being so difficult to maintain that you're afraid of it. And some of the things that you can do to tackle that is design your system with modular components. Imagine, rather than building the monolith or even just an n-tiered architecture with your presentation separated from your business logic, from your data handling and how your storage works, sort of that's a classic n-tiered architecture. Can you actually do things in a more modular fashion? And one of the things that one of my favorite design patterns is just the Unix operating system. That you have all of these little capabilities, and everything in Unix is a file. Everything has standard in, standard out, standard error. And you have different operators, pipes and carets and things like that, just to be able to, with very simple components, do amazingly powerful things. And just that simple metaphor of everything being a file makes it very easy to think through what you're going to do. So as you're designing more complex systems, because you're not, I mean, yes, the Unix operating system is complex, and the simple things that you can do even just with the command line are very powerful. But if you're building larger systems, think about building those components in a way that one component does one thing really well, and there are easy ways for those components to be put together. If you think about something like AWS, you get storage, compute, memory, and networking, four basic components. There are lots of different instance types. There are lots of different ways you can put these things together, but even AWS takes those components, puts them together in managed services, such as Elasticsearch. And Elasticsearch then creates this set of capabilities. AWS Elasticsearch isn't teaching you or even telling you what you're going to index and how you're going to query it. They simply give you these capabilities. And in doing that, it makes it much easier for you as a developer, if you're building your own systems in this way, to then think about the specific use cases you have to be able to support, but also about building these core capabilities. You know, indexing is a core capability, querying is a core capability. And so that's sort of how do you think about your design? And I strongly recommend sort of component-driven, configuration-driven systems, externalizing hard-coded strings. I'm sure, you know, most of you, if you've done any coding at some point in time, needed to think about localizing. If you do localization after the fact, it's a nightmare. Adding security after the fact is a nightmare. Adding accessibility after the fact is a nightmare. So again, if you're trying to save yourself from that future technical debt, take some of the best practices, externalize your strings, use configuration-driven systems and systems designs. And if you're going to make your product accessible, if you're going to be serving in multiple languages, if you're thinking about data privacy and security, build those things in at the beginning. Don't cut corners on those things because they're just too expensive to put in at the end.
One of the things that I've been saying, and exactly to your point about this kind of like distributed systems, is that we're seeing a comeback of the large monoliths in software development, precisely because I think that, you know, the microservices architectures that was all the rage 3 to 5 years ago, some companies, they have realized that they were not the solution to most of the problems they had, right? People tried to apply these kind of architectures everywhere, especially like in small startups that actually they didn't know what they were doing, and we've seen some cases, sadly. But right now they just, you know, they kind of like figured out that going the monolith was not a bad idea, just because obviously you're trading off certain advantages for other disadvantages, right? But the fact that everything is, you know, everything's centralized, there's like lower latency and things like that, probably they gave more benefits to the serverless. So I don't know if what the kind of architecture that you were referring to, that you were describing, could be mistaken by going serverless for startups. So yeah. I don't know if you want to clarify that for these newcomers to the industry.
Yeah, I guess a couple of things. There are certainly reasons not to over-engineer. If you're building a relatively small system, an internal tool, I wouldn't overthink it. But I would still say, even when building internal systems, design your API first, separate your presentation from how your business logic and your data. At some point, someone else is going to come along and need to be able to extend your service or do something else with that service. And if you've baked all of your business logic and everything into the front end, I personally have found that it makes it a lot harder to go faster. It also makes it a lot harder to do testing. Is your business logic broken and you can test that with the API, or do you have to write screen scrapers and try to figure out what's happening, you know, in the UI? With serverless technologies, again, at scale, and even with smaller teams, one of the big advantages that I've seen with serverless technologies is the DevOps maintenance. And you know, for companies like Amazon and other large companies that have peak events, you have this surge in demand. And if you haven't figured out how your infrastructure is going to scale, you'll probably crash. You'll probably go down. An example of a company that really leverages elastic computing is Intuit. So once a year, America has tax season, and I think their traffic goes up by 15x. But most of the year, they don't really have a lot of traffic. So the last thing you want to do is to have to provision all of that equipment and make sure your software will scale to that level within the constraints of the infrastructure that you've got. if you can work in a more elastic and even serverless environment and let a cloud operator run all that stuff for you, I've found that that's a lot easier. We've been moving a lot of our smaller scale systems that don't really suffer from that cold start problem. So the first request that hits your serverless system has to warm everything up. So a simple technique there is to write a warm start script or a cold start script that actually warms it up before you start pointing traffic at a system. So that way you don't take that latency hit. If you don't have regular traffic and you need low latency requirements, then it's probably not the right way to go. You mentioned one thing just about like the monolithic systems.
Yes.
One of the other sort of anti-patterns I've discovered over time, going back 20 years ago, I was very proud to be working on systems that were running on the biggest iron or the biggest piece of hardware that you could. And I've come to realize that that's an indicator that your architecture is incredibly fragile. If you have to throw giant hardware at it, if you keep growing and there's no bigger hardware available, you're stuck. So distributed systems, being able to operate in multiple regions or multiple data centers, you really have to be able to distribute things if you want to maintain your availability. And that forces you, again, in my view, to think about things in smaller components and just think about how much you want to be spending on infrastructure, scaling, maintenance of equipment, and even if it's cloud-based versus just letting some cloud provider do it and running in a serverless environment.
Correct. But let's circle back. You raised a really interesting topic, which is maintainability, right? And over engineering, because I read a tweet, I think it was yesterday, that said like over engineering is directly related or indirectly related to, no, let's rephrase it. Let's put it another way. It says like people who tend to over engineer is because they know they will not be maintaining that piece of software, right? So if they knew that they were going to maintain it, they wouldn't do it. Right. So how does that relate? Because oftentimes over engineering is mostly related or goes associated to younger people, more like junior profiles who try to kind of like show off or try to show that they are proficient in the language, or maybe they want to impress somebody. They just learned something. They want to just apply it. But it's most of the times over engineering is not the solution, as you said. So how can we prevent over engineering right from the get-go in a project?
Well, I have a saying that I've developed over the years, which, in software engineering, solve a problem worth solving. And what that means is I look back at my career and some really amazing engineering that I've done, been really proud of it. And then when it was done, looked at it and said, that problem wasn't worth solving. I just wasted an awful lot of time. So start with what problem are you solving? And then ask yourself, is it actually worth solving? And if it's worth solving, is your solution the easiest one to imagine your end users, your customers using? So again, sort of thinking about, is your software easy to use? If it's easy to use, people will use it and they'll keep wanting to use it more. Is it easy to maintain? If it's easy to maintain, you can focus on what are you going to do next. If it's not easy to maintain, then you're going to get to that place where you've made it so complicated that you're afraid to touch it. And I've inherited these kinds of systems. I've unfortunately built some of these kinds of systems. And that's again why I go back to thinking through from your API layer. What is the request response contract? Think through what are the parameters that need to go in? What's the data that comes back? How can you, with best practices in security, do assertions inside your code that say this parameter is supposed to be a positive integer. This parameter is supposed to be a date. Don't let your customers or your UI developers have to deal with all of that. Harden your APIs. Make them do what they're supposed to do and not do anything they're not supposed to do. From the maintenance perspective, decide how many different languages you're going to use. I worked at a small startup of about 25 people. We had probably 8 or 9 major components in 7 different languages. Like that was just insane. We had Perl calling C. We had code in C. We had Python. We had Java. We had Jython that was trying to call Python from Java. It was a nightmare. And of the 25 people, I think probably 20 were engineers. And if we lost an engineer, we lost the one person who knew the language for that one component. And it just made no sense. We thought we were doing the right thing because, hey, this guy really fast in Python, and we've got to go fast, so let him write it in whatever language he wants. And then unfortunately, some guy came in and he was really fluent in PHP, and then we added PHP to the stack. It made it very, very difficult to maintain the code because everybody was not fluent in every language. The other thing that becomes problematic with that is how many versions of libraries are you going to maintain? How many, even if you're just using a single language, multiple libraries age out. What's your process for understanding accumulating technical debt as the software you've already built ages? And you know,
and devices
I was
as well,
working,
right?
Oh yeah, the devices as well, the underlying operating system, the operating system level libraries. I was working at Zynga, and we successfully moved Words with Friends, which was, you know, I think one of, if not the largest Ruby system on the internet. And we had, you know, thousands of instances that we moved up into AWS. We were looking at upgrading to the latest version of Memcache. Memcache had a feature that we needed, and we realized that we couldn't upgrade to that version of Memcache because the version of the operating system that we were running on, that we had imaged, was older than the company itself. It was over 7 years old. So we had a Memcache pool. Well, I'll just, to make math a little simpler, let's say it was 100 nodes. We upgraded to Amazon's Linux, and we got a 1/3 reduction in that pool. So we were able to go from 100 nodes to 66 nodes. We upgraded to the latest version of, which one was it? It's the networking library. Totally blanking on it. Oh, well, I've forgotten it. So the networking library in the operating system, we got another 1/3. So we saved another 22. So now we're at about 50 instances. And then when we finally upgraded to the latest version of Memcache, we got another 1/3 of performance improvement. So we went from about 100 nodes to about 40 nodes. That Memcache pattern at Zynga was in every game. We had at peak over 40,000 instances in our 4 data centers. So if you imagine, if we had just maintained current versions of just the operating system and Memcache alone, we could have reduced that by probably 20 to 30,000 instances of our own instances, which represented $50 to $60 million of investment. So you can just see the tech debt of just deferring the maintenance and the upgrade of just the operating system, the networking stack, and Memcache alone cost the company tens of millions of dollars over probably 5 to 6 years.
Wait. So there's something, if I got in this correctly. So you mentioned that you were using Ruby at Zynga, because I didn't know Zynga was using Ruby extensively. Wow. Okay. Like every week I find out a new company using Ruby. All right. How big was the team, and how many products did you have at Zynga using Ruby on Rails?
Actually, it was just the Words with Friends stack. So when we acquired the company, they had written it in Ruby, and so we just kept it going. There was actually an effort at one point to port it to PHP. The CTO at the time had said, you know, let's just standardize on PHP, take it for what it is, but that way, that's where our expertise is. And I think they had a team of 9 engineers who were trying to port it. And since the game was live and very active and generating a lot of ad revenue for the company, they kept working on the Ruby side of the system as well. And the 9 engineers could not catch up. I was the one who actually went to the CTO and just said, this makes absolutely no sense. It's working fine. Let's not do it. Let's kill it. Let's put those 9 engineers on another game. And so we ended up killing the PHP project.
I was playing that game so much, so I'm happy that that contributed to keeping Ruby alive in Zynga. No, just kidding. But there's another angle there, because you mentioned, you know, there's different versions of the software. There's different programming languages inside a company. You need to support mobile devices or any kind of devices, different operating systems, libraries and their versions. Therefore, also there's another angle, which is companies you acquire, which coming as yet another addition to the clusterfuck of technologies and frameworks you've got into the company, right? So how do you deal with this? Because in this case, you couldn't port because you tried to standardize, but it didn't work. Why? What was the strategy? Trying to standardize because from the investment side, or let's say financials, made more sense? Or was it because, you know, it made more sense to have just one stack for every kind of project in the company? And how do you decide when it's a good moment to port?
I mean, part of it was we actually had a contract firm that the founders of the Words with Friends game had contracted with for several years, and there was some questions from a finance perspective, some question about the risk because there were just two guys. If they got hit by a bus, who was going to maintain the core code? Since we had tons and tons of PHP expertise, we could move engineers onto a PHP stack and they could be productive immediately. They didn't necessarily know Ruby or didn't know the best practices. And then the only people that really understood the Ruby stack were the only people that could do the upgrades. So we were constrained. I think the team was about 30 people. And we did have churn. We were able to bring new people in and they could train up, but it was a challenge just from the personnel perspective. At the end of the day, I think in that case with a game that's that popular and successful, just invest in better training, better techniques, making sure you've got, separate either a DevOps model or separate your engineering and your ops, and just make sure you develop the right experts if that's the language you're using. I mean, we have some components in our customer service stack that are over 10 years old. They're C-based and nobody's modified them in 8 years. And it's kind of terrifying.
But how do you keep a mental map of everything that's going on in the company? Because even like on a daily basis, I talk to companies whose CTO say like, look, we've got this, we've got that, blah, blah, blah. And there's like a 10% of the company that we don't know where that happens. We don't know. We know there's a process somewhere. We don't know where that happens. We don't know who built it. We don't know in which, programming languages that been built. It's kind of like a black box. It's somewhere. Can you help us to find it? Right. That's the kind of project that we sometimes get. It's incredible, right? So I assume you've had to deal a lot with that.
Yeah, and I've been in role for about 8 months. Before that, I was the VP of the mobile shopping app. So big shift from mobile. We had 10 years of tech debt in iOS and Android that we had to deal with. A lot of the same types of problems, but we were supporting. Really, up until just recently, we had never sunset a version of the app. So there were people out there shopping in the Amazon shopping app that was 8 years old. People who are actually still shopping with the app on the Fire phone that doesn't even exist anymore.
Yeah,
and
I remember that.
We looked at it and we said, this isn't making a lot of sense. It's a few hundred people or 1,000 people. They're not generating a ton of income, and we have to take support for all of this. We were also running an entire web array as a proxy layer that the older versions of the app spoke to, where the more modern ones spoke to a more modern set of APIs and public internet endpoints. But I had to have 3 engineers maintaining this fleet that was taking 7 billion calls a week, and that was a waste. So what we actually did is I think we took too long, but we actually went through the process of first putting up a soft gate, letting people know that we were going to be sunsetting the version of the app, and then finally putting up a hard gate and preventing people from using the older versions and forcing them to update. What we found was 3 really interesting things. First, all of those customers ended up engaging more and spending more because the modern version of the app was faster, had more features, was just easier to use. All of the research that we'd done, all the A/B testing that we had done actually produced a better product, and they shopped more. So that was great for the customers. 2, we were able to reduce the 3 engineers to sort of a half-time on-call to maintain, because we didn't get rid of all the versions that still referenced that web array, but we went from 7 billion requests a week to under 1 billion requests a week. So we actually saved money for the company because we didn't need to run as much infrastructure. And then finally, we were able to remove over 500,000 lines of code. And to me, from just a build perspective, from a binary perspective, from a quality and testing perspective, getting rid of all of that tech debt was just a win for the customers, a win in terms of the expense, and a win for our developers. But again, we had accumulated 7 to 8 years of debt and ignored it. So doing that, cleanup is super important. How do you actually address it? Again, I think defensive best practices in coding are know your caller. So if you have an API or some service, even if it's an internal service, who is calling you at some point? And then with the packages, have attribution on any packages or the software. Who owns it? And when that owner leaves, you have to find a new owner. you don't want a bunch of unowned packages in your systems, because then when something breaks or you think something's broken, there's nobody who knows how the thing works. So it's a question of attribution in your packages and knowing who your caller is. The reason knowing who your caller is so important is if you're maintaining a service and it's still getting 10,000 requests a day or whatever, million requests a day, and you want to be able to turn that service off. If you don't know who's calling you, who are you going to talk to? If you want to not turn it off, you want to hand it over to somebody else, who are you going to hand it over to? Because you don't know who's calling you. I've worked on systems where it was, the number of requests was coming down to a trickle, a few hundred or a few thousand a day, but we didn't know if those were mission critical. When we finally started, sniffing things on the network to figure out where was this coming from, we found it was a test that was just running periodically. It's like there was nobody running it, nobody needed it, and we were afraid to touch it because we didn't know whose it was, we didn't know if it was mission critical. And kind of the other thing that we've started doing is we're in sort of a massive effort of reducing technical debt and deprecating and then eliminating a lot of our code. We do what we call a scream test. We just turn it off and see who screams. And it's a terrible way to
screaming.
Yep,
that's a good one.
If somebody, you make sure you can turn it back on again. But sometimes if you don't know who it is, you don't know who owns the code, you just have to turn it off and see what breaks. And that's really a terrible thing to have to do.
So you talked about there's obviously the cost of running old software in the company, then this opportunity cost, because as you mentioned, these customers were using an old version that wouldn't allow them to interact so much or have them such a great experience as with the new version, so therefore they were spending less. But I think there's another angle here, and correct me if I'm wrong, but also one of the bigger problems with technical debt is it's also with employee motivation. Right? It might cause burnout because nobody wants to work with old versions. It's very rare that somebody says like, yeah, let me work with Java 4, whatever, right now in 2020, right? Most people will not like to do that. Some people will see it as a challenge, but they're very rare. So obviously these kind of projects end up being the kind of project nobody wants to work in, right? So how do you deal with that? And was that also determinant in the process of removing or sunsetting these old versions of the technologies you were using?
Yeah, I guess for better or worse, I'm one of those people that loves killing software. And a lot of people look at sort of ongoing maintenance of old systems as keep the lights on. So what's the minimum amount of work that you can put into something so the lights stay on?
That's a great concept.
I like to turn that around and have started using a phrase, TTLO, turn the lights off. What do we have to do so this thing never runs again? And often that's building the next thing, hopefully in a modern tech stack with better practices, and then you have some kind of a migration from the old to the new. In terms of how do you motivate people when they're having to do maintenance on really nasty old systems, ideally you find somebody like me that loves doing that stuff and motivate them to kill it. I find that with old software, your best practice is if you have a handful of subject matter experts and you're putting them on undifferentiated work, like maintaining old systems, that's a waste of talent, a waste of your money, and you're probably going to demotivate and lose those people. So if you can motivate them by saying, we're going to kill this thing. So what's the path to eliminate it? If I can't eliminate it, can I automate it? And if I can't automate it, can I delegate it to somebody else who's not a subject matter expert so that I'm not wasting that time? So sort of eliminate, automate, or delegate. In terms of the eliminate, that can actually be quite motivational if you position it well. And it's not to manipulate people, it's actually to help them think bigger. So I often have sort of mid-level engineers saying, this is an entry-level engineer job. I don't know why you have me doing it. It's like, nobody should have to do this job. Think about it as a senior engineer and make this work go away. And I usually see their eyes open and they go, I didn't think of it that way. It's like, solve the problem so no one ever has to do it again. Don't just sit there and do it over and over and over again.
Sure, but one of the main objections finance people will have, because obviously tech will see it's good for the company and it's good for the product, it's good for the team. And let's refactor this, let's rewrite the API, let's change from this framework to another one. Let's rewrite the mobile apps every 2-3 years. But finance or operations or even the CEO will be like, no, like we cannot afford to spend time on that. Priority is marketing, priority is this. So obviously you need to be either like a CTO that's very well oriented in business, so business oriented, or you need to be very good at sales inside the company, right? Selling these kind of projects to the company, because sometimes it's not a matter of money. Like it's hard to justify how much money you will be saving or even gaining with these kind of projects, because you can see that in hindsight, but it's hard to predict, right? So how do you sell these kind of projects to finance people in the company?
Well, I find that anytime I have to sell or pitch, I'm most effective when I can back my story with data.
Yeah.
And when it's
From
just
previous
opinion
projects, I guess.
well, actually, no. So I have I was at a startup. It was about a 35, 40 person startup. The CEO was very ambitious. The company was doing very well. We were onboarding a lot of customers, and he wanted us to be shipping a lot more product, lot more features. And he thought we should be able to have about 80% of our engineering team shipping new features, and about 20% running the show. And I just said, that's just not how it is. He said, well, I don't believe you. So for 2 months, I tracked what every engineer did down to the hour, which was tedious, and I never want to have to do that again. But at the end of that, I had for every week, over a 2-month period, every engineer and what they spent their time on and what category of work that was. And I then took that to him and showed him exactly what it was, and it was the exact opposite. 80% of our engineers were just maintaining the system and onboarding customers, and 20% were available for new feature development. Once he had the data, he realized, okay, well then we're doing this wrong. We need to invest in automation or elimination so that those people don't have to do that much work anymore. So to the extent that you can back it with data, that's great. I think another one, at Zynga, again, some Zynga games are hits and they're what we call evergreen. So Zynga Poker and Words with Friends, they're still around. Zynga Poker was, Zynga's first game. So they've run for many, many years. Other games sort of had a life cycle. If they were terrible, of months, if they were decent, and even if they became a hit, many of them were just a few years. The downside was people didn't want to shut the games down. And because, obviously the players who were still playing, tens of thousands of people were still having fun. They were still spending money in the game. So it seemed like from a business perspective, like, why would we want to take this away from customers? Why would we want to kill those revenue streams? But again, just went back to the data, figured out how big was the infrastructure, how many people were spending how many hours a week running these things, and just how unprofitable were these games. And then using that story, that the lack of profit in these games are negative profit. They're costing us more than they make. And those resources, the physical, compute resources and the people, could have been working on something that was generating revenue or generating profit. And so just, again, using the financials to show this doesn't make any sense. And yes, it was not any fun to sunset games, but it became necessary. The easier part for most of those game developers was, as the CIO, all of that infrastructure expense was in my budget. So they were spending money that I had to manage, and I kept getting all the pressure to reduce cost. So I became sort of, the executioner of games, because I couldn't afford it in my budget, and I had to be able to make the case. But again, that gets rid of a lot of technical debt. You kill old games, nobody has to maintain it anymore.
Yeah, but I guess that because you had the budget, because probably it was you working at Zynga, and it's a company that's so big that every department has got their own budget, and you're supposed to do that. But maybe in like smaller scale startups, there's only one person responsible for financials, right? So, and therefore and most of the time CTOs at this stage of like companies under 50 people, maybe even to 100, they're not business savvy. If they're CTOs, they're just purely the kind of CTO that has probably built himself or herself the code of the first versions, still codes some hours per week and all of that, but they have no business training. Maybe they have helped a little bit in the fundraising, but it's not like working in a large corporation that perhaps Zynga became, right? So in this sense, these kind of CTOs, they will not be able to understand the technical implications or budgets, right? So is there some way that the CTOs can get trained in this kind of implications or in basic business?
I imagine there are. I had the
How did you learn?
unfortunate experience. So back in the 90s, I was working at Electronic Arts, also a game company, but I wasn't working on the game side. I was working on the information services side. And I was asked to meet with the CFO and the director of finance to help them assess building out a P&L management system.
Right,
I said,
yeah.
sure. I didn't even know what P&L stood for. I just said, sure, let me hear about
like
it.
most developers.
And they said, it's very complicated, and we're going to walk you through. And by the end of the meeting, it was probably a 60-minute meeting, I realized they wanted me to write computer software to add, subtract, multiply, and divide numbers.
Yeah, all right.
Like, that's it. Profit and loss, it's just adding, subtracting, multiplying, and dividing numbers. It's like,
Correct.
yeah, that's pretty easy to do in software. We actually, it took us several months to build out what we needed, and then we were able to distribute that worldwide to all of their finance people and the general managers of the games. And it was a very interesting experience because I learned how we thought about the expenses of games. So what's revenue? What's the cost of goods? How do you then get to the net revenue? And then you sort of work your way all the way down to contribution margin, and then finally net operating profit. And I learned it because I had to build software to do it. I would imagine there might be easier ways to do that with books or classes, but that particular period of time served me very, very well because I understood how business leaders thought about things, both from the CFO perspective as well as the general managers. And the general managers were just looking at every last expense that was getting allocated to their game. They wanted to know, well, why do I have to pay for this? Why do I have to pay for that? They didn't want to pay for anything that they didn't think was direct to their game, the people on their game, the equipment that they were using. But we obviously, as a large company, had all kinds of other overhead, and everybody had to pay a share of that overhead. So we did what are called allocations, where you just peanut butter things across. And the general managers never liked that. The same thing was true at Zynga. When I was running all of the central services, from customer service to quality and testing, internationalization and localization, all of the infrastructure costs, I ended up having to defend all of those numbers and the chargebacks to their games, because ultimately we wanted to know which games were making the most money. And it's just a question of understanding the numbers, understanding the data, and being able to tell the right story when you have to speak to management.
And how about, because when you're pitching this, we're talking about having to pitch to finance people or operations or the CEO or even to investors or whomever, right? But you want to pitch them, hey, we came to a point in which we cannot work with this API anymore, or we cannot use this mobile apps anymore. We need to rewrite them. And they will ask, okay, fine. What's the estimate? Let's talk about this thorny topic. Yeah. Estimates. Yeah. How do you go about them? What's your opinion? In our last episode, in the Spanish podcast, we were talking to Xavi Noria, one of the core contributors of Ruby on Rails. He says, I've never worked with estimates in the last 18 years of my life, something like that. And the way most open source projects work, they've got no managers, they've got no meetings, they've got no estimates, they've got no project managers and things like that. And it's incredible how open source software has taken the world of software and even enterprise by storm, but still it conflicts directly their philosophies with the philosophy of enterprise, right? So how do you go about the estimates, and how can you produce ballparks out of the, of the magic hat, right? How do you pull the rabbit when they say, hey, we need to build this, how much it's going to take? I don't know, right? How do you go about it?
Well, I guess the difference there is probably a different perspective on accountability. That, for the open source community, they are certainly accountable to the community, they're accountable to the quality, but they're not accountable to deliver specific things in specific timeframes that will have major financial implications. And I think for enterprises particularly, but even startups, you had to have some sense of either you're doing something that is truly a science experiment and you don't know what the outcome is going to be, or you're doing an engineering project where it is engineering. There is a methodology and you can figure out with this kind of input, what's the output I expect to get. With the science types of projects, a guy I worked with about 10 years ago gave me a really interesting way to think about that. He said, when you're presented with something and you have to generate some kind of an outcome, and you really want to go the science path, really experimenting and doing, innovation and invention, but it's risky. You don't really know how to get there. Step back and say, well, you've just had to engineer the solution with what you know. How long do you think it would take? Break it down into the smaller pieces and add whatever fudge factor you need. I found that when I estimated things, I would estimate based on the amount of time I thought something would take, so the effort. And then I would realize that it always took 3 times longer because of the elapsed time and all the other things that I would have to do. There's never a day as an engineer where I was coding for 8 hours or 10 hours a day. There was always other stuff that I had to do. And it turned out meetings and all these other things ended up tripling how long it took me to do something, although it was still the same amount of effort. I think the one thing that I found with estimating, 1, you're always going to be wrong. 2, something really nasty and unplanned is going to surface, so give yourself some buffer. And 3, measure. It's like forecasting. You want to make your estimates and then measure and then see how close you were to it. Just what was your variance between what you thought it was going to take and then what it did take. And the other point is understanding not everybody's estimates are with the same level of precision. So you actually want to know who made the estimates. And then ideally, if you really want to nerd out on it, take goals for improving your estimating forecast variance and try to understand what are the best practices, who are the people that are best at estimating, why are they better at estimating. So you can actually dive deep if you collect that data and understand estimating itself as a problem space.
I remember when I was working as a developer in these big consultancies, and they always asked me like, how long this is going to take? And one of my favorite answers was, I can estimate how long is it going to take for me to code it. I cannot estimate how long is it going to take for me to sit down to actually code it, right? Because I kept getting all these interruptions, and I was lucky if I had 40 minutes, like slots of 40 minutes to work on the software I was supposed to develop, because I was all day long trapped in meetings, right? Yeah. So in this sense, the culture of interruption is something that it's out there right now. We're seeing more often than not more companies trying to transition to asynchronous workspaces, whereas the synchronous culture is kind of like not doing so well maybe nowadays. But one of the things I noticed is that one of the most undervalued skills one can have in business is setting expectations. And I think developers were not very good at that, right? We always think about the most optimistic scenario. I would say like, I think this will take 5 days, but I will say 4 because I will be fully focused on that. And I think like 5 days, they will not accept it. So I will go for 4. That's like, no, if you think it takes 5, you should say 15. Like you said, 3 times more, because then it gives you time to actually negotiate it down to 10, and it's going to be more correct than 5, 4, or 15, right? So how do you set the expectations, and do you usually, as you started making this kind of estimates, would you put more buffer, or depending on the people you were talking to, or depending on the kind of project, what are your rules for producing these estimates for your own estimates?
I'll get to that, but I think there's a flip side to this. Is sometimes when I need to get estimates from other people, what are the right ways to do that? And a story I have is, again, at Zynga, I was a CEO. I'd been the CEO for about 3 months. The business was not going well at that time. The CFO and the CEO and the COO came to me and said, "You've got the biggest team and the biggest budget. What are you going to cut?" And I looked at, we had 4 data centers in 4 different locations around the US. We had over 42,000 servers in our own private cloud. And most of the equipment was 4 years plus and failing, very difficult to maintain. Most of the experts that had been hired to design all of that infrastructure had left the company. And I just saw this massive amount of waste. So I went to my new team and said, okay, if we wanted to thin this down and migrate all of this up into AWS, how long do you think it would take? And they just went, what? We can't even do that. That's not possible. It's like, well, we have to do this. We have to reduce the cost. And they said, God, we couldn't. It's going to be 2 to 3 years. I don't even think now there's no way we could do it in 2 years. And so I said, well, what if I wanted it done in 5 months? And they all went white. And I said, okay. They said, that's impossible. I said, well, what could you do in 5 months? And they said, well, we think we could consolidate our largest and oldest data center into half the space and retire half the equipment. I said, great, let's start.
That's
And
something.
while we're doing that, we're going to learn we're going to learn and document our best practices. And before that 5 months is up, we're going to start work on the next data center. And we're going to learn as we go, and we're going to start on the next data center. We actually were able to consolidate 4 data centers down into a single data center in about 12 months. And in about the next 5 to 6 months, we moved everything up into AWS. So what they said they didn't think was even possible at first, and then was likely going to take 3 years, maybe 2, we ended up doing about 15 to 16 months. So part of that was we didn't know how to estimate it, so we learned as we went. And I think that's actually applicable in many cases. If you don't really know, just start and learn by doing.
Yeah, it's more like you chopped it down to smaller chunks, right? Because if you try to tackle a really big project, which is the case, right? More often than not, technology companies come to us and say like, hey, can you estimate this project? Like literally, I think it was yesterday, we got a company from the Middle East, and they wanted us to produce some sort of Amazon clone for a shopping mall, like a bespoke e-commerce, fully fledged with 3D visits of their own floor plan, streaming stuff from their cinemas, and a fully fledged Amazon, right? I was like, well, no, that estimate cannot be done. I was like, it could be millions of euros, right? If you think of this way. But maybe what our approach is, hey, let's chop things down. Let's try to reduce the scope and try to figure out what things we can do. But also sometimes it's just turning question inside out, and it's like, let me know what your budget is or your time frame is. When's the deadline? And I'll see what I can do with this budget or this amount of time, right? So sometimes it's not, estimates don't work so well because you're just producing a random number. But if you told me upfront and beforehand, you told me, hey, I've got this much money, that needs to be done by December 31st. I could say, okay, maybe it would have been a better start. Now I can say what I can do to comply with that, right? So I don't know, does that really help also when you're trying to, because you mentioned earlier on that one of the ways to deal with legacy software was also to eliminate or to delegate when you're trying to outsource or you're trying to work with external, contractors. How's your approach?
Well, it's interesting, just that same thing. If you take a very large problem and you break it down into n smaller problems, you need to recognize you now have n+1 problems at a minimum, because you got to put them all back together again. So that's your plus one. But what's interesting, both in terms of breaking things down for estimates and kind of going full circle to where we started, how do I think about architecting systems? Having smaller components that are capable of doing one thing really, really well, having smaller teams that are capable of doing one thing really, really well, is a way of modularizing your approach, both to estimating as well as to the software development and ultimately the software design and architecture. So breaking things down into smaller pieces, making sure those smaller pieces do one thing really, really well, and you clearly understand how they plug into other things and can be configured together so that you can mix and match these things. The same can actually be true of the estimating side of it, where you can understand what are the smaller pieces, how will these pieces integrate, and what timeline do I need? Which are the things that are the hardest? Which are the things that are potentially the easiest? And then in the estimating process and in that kind of a project, how do you want to prioritize quality, scope, resources, and time? And some projects, it's like, this is, for the medical field, quality has to be at the top of the list. And so if you run into problems, you're going to reduce scope, or you're going to take longer, or you're going to add resource. Or if you say, I have a finite amount of resource and I can't add any more people, I can't spend any more money. Well, if you have to make a trade-off, you're going to sacrifice quality, you're going to sacrifice time, or you're going to sacrifice scope. If the scope is, this is the minimum viable product and I can't change that, again, it's really important, I think, that when you're meeting with whoever your client is, or if you're meeting with the CEO, if you're at a small startup and you're the one who has to put this together, get the buy-in up front. In what order will you trade things off? Unfortunately, often quality is number 4. And that's the one that goes out the window first, and that's how you get into the tech debt. But it's understanding those four things, just in terms of time, resource, scope, and quality. Every project does not order those in the same way. And being really upfront about it, so that when something goes wrong, because something will always go wrong, you know where you're going to trim. And your client or your CEO or product manager is in alignment with you already. And if they start changing the order of those priorities, your project is probably going to fail.
So they don't care that much if you got 24 concurrent versions of jQuery, right? So I remember you mentioned that in one of our conversations. Can you explain that story? Because I want to hear more.
Oh man, yeah. So I mean, we're looking at an awful lot of tech debt across a number of different areas, and over time, whether there's security vulnerabilities or just lack of efficiencies, this particular system has been developed over the last 15 years by teams that come in and add their own set of features and then sort of leave them for the central team to own and operate on an ongoing basis. And I think over the last 8 years, we've had teams come in, contribute code, and there are 24 versions of jQuery in this tech stack. And that's just insane. When I heard that, I kind of just said, all right, we've got to clean up. Again, kind of going back to that tech hygiene theme, how many versions of your core software do you want to have to support? And again, whether it's just complexity, compatibility, security, it doesn't make sense to have more than 3 versions. And that's, usually you should have, you're experimenting with the latest version, you've got your stable version, and you might have some things where you're still migrating to the latest stable version. And I feel you have to have a routine where you're looking through, analyzing your code, understanding your software dependencies and the versions, and then set a policy. And if you have actually automatic code analyzers, set policies and set alarms and be alerted when things are approaching being stale, or they're crossing your thresholds. I mean, I don't think it makes a lot of sense to have core software that's older than 2 years. You shouldn't be two years, or you certainly don't want to be 2 major versions behind. And I've worked on systems that were 5 or 6 major versions behind, and you're running on version 2.1 and you want to get to version 6, and you can't just go from 2.1 to 6. You actually have to go from 2.1 to 3, and then from 3 maybe you can get to 5, and then you get from 5 to 6. And just those kinds of projects are long hauls, they're demotivating, and they're usually quite fragile.
Yeah, and that's true for private companies, but for public administration, I can tell you there are 6 or 7 or 10 versions behind. At least over here. What's actually speaking about that is there's one saying over here which goes along the lines of if it works, don't touch it, right? Which is not a very responsible way to address things, because especially things might catch fire. And I think you've got a story about that. But before we go into that, I know there's always the other concept is last responsible time to deal with anything, right? The last time to deal with a software that breaks is when it breaks. The last responsible time, it might be, a conflicting version, deprecated version, or maybe before you will lose the engineer that wrote that piece of code or whatever, right? Is that something you also take into account, and the last responsible time? And then if we can go into the story of data center catching fire, because that's pretty impressive. It's a good example of not maintaining stuff, right? So,
I mean, this is probably more lip service than actual practice, but I do view it as quality by design. The best way to do it is design your quality in at the beginning. As I'd spoken about, localization, accessibility, security, building those things in at the beginning, and then having tests. I've worked only at one company that had test-driven development, and it was fantastic. Before you wrote code, you wrote a test, and you knew your code was done when your tests passed. We actually migrated the entire tech stack from Sun OS and Oracle to Red Hat Linux and MySQL in about 3 months. And this was a startup we've been running for about 3-4 years. So I mean, there was a significant amount of code that had to be addressed. We had 96% test coverage, and we had a high degree of confidence when all of those tests passed, we didn't really have to spend a lot of time worrying about whether we broke something. Later on, we actually ported all of that to run on Windows, and it was an email system, run on Windows and talk to Exchange, which was not anything we'd done before. And again, we were able to do that in about 3 months with about 2 engineers. We had a high degree of confidence because our tests passed, as long as our tests were compatible across things. So to the extent that you're not waiting for things to break, that sort of last responsible point is actually as you're checking your software in before you deploy it. It's like you should have that test coverage. It's a wonderful feeling to be able to have all of your tests pass and know that you have a tremendous amount of test coverage. Things can still go wrong, but you really minimize a lot of that effort. Our ability to move that fast in transforming our underlying architecture and even the operating system allowed us to open up major new revenue streams and new lines of business. So it wasn't, all of the testing that we did enabled this, and because we were able to move quickly, we were able to get into new markets. So it was actually quite a success story there.
That was the same company whose data center you had to move with a truck because it
no,
caught fire?
no. So at
Technorati,
we were a scrappy startup, probably 20 people. Technorati was a blog search engine back in the mid 2000s. We actually had the largest near real-time search index on the planet. We had over 8 billion documents indexed at that point. Google at that point was about 4 billion documents. And it was a lot of fun. I really enjoyed that. But our data center was in the South of Market district in San Francisco, in one of the sketchier parts of town. But we got a really good, per square foot rate. So we were saving a lot of money. I remember getting paged and having to rush down. An electrician had been working out on the street, and he wasn't certified. He made some mistake. Luckily, he didn't kill himself. But what he did in doing that, it actually started a fire in the data center. And so we were literally on fire. This wasn't just a emergency. The software is on fire. That people often say. No, that the data center was on fire. They were able to put the fire out.
Literal fire, yeah. Literal fire.
They were able to put the fire out, and we realized we weren't going to have power in that data center for a while. And we rented a trailer and unplugged all of our equipment and stacked it in the back of this trailer and drove it over to a new data center we had been looking at, and we moved the whole thing, and we got the site back up and running.
How long had elapsed in between?
We had realized we needed to change data centers, so we had a footprint in the new data center to some extent, but we hadn't been ready to flip the switch. So I think, if I recall correctly, we were able to flip the switch to at least put up a sorry page, and then over the course of several hours, we were able to bring up the rest of the services.
Maybe it was somebody who wanted to speed up that process. He was getting upset that this was not moving and the CEO was not approving the batches. Like, fuck it, I'm going to burn the office down if you don't do it. Anyways, last question to wrap this up, because we're already approaching the hour. And so one question we'd like to ask to our speakers, and we're trying to make a failure more acceptable for everybody, right? So what's the most, the biggest technical mistake you've ever done, and if possible, the costliest as well, the most expensive?
Oh, wow.
Needs to be your fault. We are not interested in anybody else's. Yeah, because it's easy to speak about other people's. Like, a friend of mine did that, right? But
just in the interest of time, I can't think of what was the biggest failure, but one that taught me a lesson. Again, Technorati. We, as a startup, our systems did fall over quite often. We got pretty good. We created a configuration file, which we called BRB, which was the big red button. So it was just a config file for each of the different services, 1 or 0, is it on or off? Pretty simple. We ended up realizing, well, if we turn something off, we need to message our customers. So we implemented the ability to map any feature to an XML file that contained messaging that we could display across the top of the web page, sort of in a message of the day fashion. And so we renamed the big red button to Be Right Back, but it was still BRB. And one of our services went down. I was on my way to get my hair cut. I'm
the
like,
last
oh,
one
nuts.
I see. The last one.
Yeah,
I see.
probably.
The last one ever.
So I've got to turn the service off and put up the message. I scramble to my computer so I'm not late for my haircut, and make the change, push it live, go to the hairdresser about 10 minutes away, and check the site, and PHP white screen of death.
Yeah.
Wait, what? So I turned to the hairdresser. Hey, can I borrow your laptop? So
Did you do it?
It's like connect to our hosts and go check. And I had an extra comma in the config file.
Oh.
So PHP couldn't parse it. That's like just a lint check. So like so dumb. Like all of these lessons learned and why you do testing and all. It's like that was just the dumbest thing. So it wasn't that costly, but yeah, I personally took the site down for about 15 minutes because of a comma.
Yeah, that's just a comma. It's one thing that's always hard to explain to people when you're a developer and they kind of, what happened here? You cannot just tell a bot of a corporate, I forgot a comma or I wrote 2 commas, because they will not understand how that shit brings entire castle down, right?
Yeah.
Anyways, I think
Absolutely.
It's a great way to wrap it up. Thank you very much, Dorion. Any last
Thank you,
words
Alex.
for our audience? If there's something that you want to say to our audience, there's new people.
Well,
this episode number 7, 6, 7, something like that.
Well, I hope some of these stories were helpful, and I hope you can put them to use. I often recall, when I'm looking at software, how can I make it better? How can I put that quality in? How can I put comments in the software? Because 6 months from now, some poor bastard is going to be looking at this code. What was this idiot thinking? And that idiot was me. So yeah, I try to leave little breadcrumbs for future me.
God save, Git blame, right? All right. Thank you very much. See you in the next episode, everybody.